So now we have discussed the method of arriving at the secant formula. Now let us solve a problem. So solve x cube plus 4x square minus 10 by secant method. So this is a cubic function, hence you will have 3 roots, and if you plot this function, the behavior of this function will look something like this. And for this function, we have one real root given by x1 is equal to 1.365 and the other two roots are complex roots. So as we know that we need two initial values, and we start with the initial values as x0 is equal to 1 and x1 is equal to 2. Now we write down the secant formula for obtaining the approximate root x2, so which is equal to x1 minus f of x1 into x1 minus x0 divided by f of x1 minus f of x0. So we know the initial values x0 and x1, and the function f of x is x cube plus 4x square minus 10, and we can substitute the initial values to find the value of the function at the initial values, that is f of x1 by substituting f of x0. So this is f of x0. If we substitute x0 as 1, so we get minus 5, and x1 by substituting x as 2 in this function, we get f of x1 is equal to 14. So now we know all the values. X1 is known, f of x1 we have just evaluated, x0 is known, and f of x0 we have just evaluated. So now substitute all these known values to find x2. So x2 is equal to x1, that is 2 minus f of x1 is 14 into x1 minus x0, x1 is 2, x0 is 1, so it is 2 minus 1 divided by f of x1 minus f of x0, f of x1 is 14 minus f of x0 is minus 5, 14 minus bracket minus 5. So if you simplify this expression, we get the value for x2 as 1.263157. So this is the first approximate root after the first step of iteration. So if we evaluate the function at this x value, we get f of x2, which is minus 1.60229. So we see f of x0 is minus 5, f of x1 is 14, whereas f of x2 is minus 1.60229. Hence we are approaching closer to 0. Now we have to update our approximate value to find the next x value by substituting the previously determined x value. That means we find x3, which is equal to x2 minus f of x2 into x2 minus x1 divided by f of x2 minus f of x1. So all these values are known. x2 is determined now as 1.263157. f of x2 we have just evaluated, and the other values of x1 and f of x1 is already calculated. So if you substitute all these values, this results in the value of x3 as x3 is equal to 1.33882, and if we compute the function value at x3, the function value is minus 0.43038. So you could see that it fastly approaching the 0 value. So if you repeat this step further to obtain x4 and other values of x, we get x4 as 1.366619 and f of x4 is equal to 0.01586. So you could see the function changed its sign, and hence the root has to lie between x3 and x4. That means 1.338 and 1.366. So if you repeat the process, so we get x5, which is equal to 1.365631, and the corresponding function value is 0.006623. So which is fast approaching to 0. And the next iteration we get a value of x as 1.36492, and if you truncate this to 3 decimal places, 1.365, and the same value is obtained in the previous step as 1.365 up to 3 decimal places, and hence we can stop the iteration, and the required root for this function is x is equal to 1.365, which is correct to 3 decimal places as shown here.